some other things we need to know about trig. These are mostly covered in section 9.7. We won't do anything specifically at the moment practicing these problems, but these are concepts you need to know. First thing, you know that the sine of 30 degrees equals 1/2. What if I said the sine of what angle equals 1/2? So the sine of what angle equals 1/2? Your answer, 30. But I don't want to say what is the sine of what angle equals 1/2 or cosine or whatever the values happen to be. I want to find an easier way to ask that question. One way to ask that question is the sine of theta equals 1/2. What is theta? Well, it's saying the same thing. The sine of what angle equals 1/2? 30 degrees. I could use inverse function. Sine -1 power of 1/2 equals what? Again, this is saying the inverse, and if you notice, this is what your calculator has. If you look at your sine button on your calculator and you look at second sine, it's the inverse function, which again will give you 30. Another way to write the same thing, instead of using sine to the -1, which means inverse, we have arc sine. Arc sine means inverse sine. It's exactly this, just written arc instead of the -1. So this is 4 different ways to ask the same question. The sine of what angle equals 1/2? Answer is 30 every single time. So I can ask it like this, which you probably won't see. This could say solve, what is theta, or solve. It could say to solve this or to solve this. All of these mean the same thing. So make sure you understand what the question's asking, because it's a simple process. The other thing you need to know, we talk about 30 degrees. Everything's in degrees. But degrees can be broken down. We can talk about hours. It took us 1 hour. But we can break an hour down to 60 minutes. And we can take a minute and break it down to 60 seconds. So we can be more precise. So if I said I had an angle that was 30 degrees, 40 minutes, and 10 seconds. So we already know degrees. This is just like a clock. Minutes and seconds. So we have hours on a clock, we have degrees, minutes and seconds. So the comma should not be here. So we have 30 degrees. How do I write 40 minutes in 10 seconds in decimal form? Minutes is out of 60, just like a clock, and seconds is out of 60, just like a clock. So this is 40 minutes out of 60. And this is 10 seconds out of 60 minutes, and there's 60 minutes in a degree, so it's out of 3,600. Just think if you were going from seconds to an hour. How many seconds are in an hour? There's 60 seconds in a minute and 60 minutes in an hour. So 3,600 seconds in a degree. So we can do the math. Take 40 and divide it by 60, or 2/3. Right? 6 repeating. Take 10 and divide it by 3,600. You get 0.0027 repeating. So if I wanted this to 3 decimal places, 6 repeating would round to 7, and the 2 would round to 3. Add those up, 30.670. So 30 degrees, 40 minutes, and 10 seconds is the equivalent to 30.670 degrees. Let's say we want to go backwards. Let's say you get an answer of 40.5 degrees. And the answer you want, they tell you they want it to the nearest minute. Well, typically when we go from a decimal to a fraction, we say it's out of 10. But again, go back to this, that it's in 60 minutes, 3,600 seconds. So ignore the 40 for a minute. 0.5. 0.5 is 5/10. We need it in terms of 60 because there's 60 minutes in a degree. Cross multiply. 6 times 5 is 30, so 300 equals 10x. Divide by 10. And you get 30. So if I said take 40.5 degrees and convert it to the nearest minute, write it in degree and minutes, your answer would be 40 degrees, 30 minutes. Notice 1 slash for minutes, 2 slashes for seconds. Okay? So once in a while you might be asked to go from decimals to degree, minutes, or seconds. And all you have to remember is think of a clock and then convert it. Minutes are out of 60, seconds are out of 3,600. Add up your decimals. Or take your decimal, write it as a fraction, do a proportion over 60, and solve.